Okay, let's do some complex numbers. So I'm going to go through this revision sheet, going to go as quick as we can through it, pointing out some key bits to watch out for, some ideas, just that usual sort of thing. So Z1, Z2, okay, remembering that with complex numbers, when you would have done it originally, all your complex numbers are written as Z is equal to, and that's the general form, is A plus BI. A and B are usually just numbers. So complex numbers just have this particular form where like Z1 is a complex number, but we can write it out as like an extended form. So the right hand side, you can really think of it as like its full name, whereas the left hand side is like the nickname. So Z1 is minus 3 plus 4i, Z2 is 4 plus 3i, and I squared is equal to minus 1. Okay, that's the key part with complex numbers. First of all, we have to plot and label Z1, Z2, and Z1 plus Z2. So let's start with Z1. Z1 is minus 3 plus 4i, so we go to minus 3 on the real axis, we go up to plus 4 on the imaginary axis, and that'll be Z1 there. Looking at Z2, it's 4 plus 3i, so we go over to 4, we go up to 3, and that's Z2 there. Then for Z1 plus Z2, we're going to just use the full names, if you like, so minus 3 plus 4i plus 4 plus 3i. And remembering that we can only add like terms, similar to our algebra. So we can add the i's and we can add the numbers. So minus 3 plus 4 becomes 1, 4i plus 3i becomes 7i, and then we plot that on our graph up here, and that's Z1 plus Z2. Okay, so that would be your first few marks there. The next one then, Z3. So they're telling us Z3, this is a new number. And Z3 is Z1 divided by Z2. Okay, to divide by a complex number. Okay, so first of all, actually we can write out the start of it first. So Z1 is minus 3 plus 4i. Z2 is 4 plus 3i. Okay, now they want us to write it in a particular form, and it's this form here, A plus BI. So what that means is that we have to simplify this down so that it's written as one term. Instead of the two, instead of the fraction, we just want it written as one simpler number. Okay, to divide by a complex number, we have to get what we call the complex conjugate of the bottom part. So the complex conjugate is usually written like the same as a normal number, but with a line over it. And what it is it's the normal number part, but for the I part, instead of it being a plus, we're now going to make it a minus. So we change the I part, we change the sign of it. So if it was a plus, it becomes a minus. If it was a minus, it becomes a plus. And what we have to do is we have to multiply top and bottom by the complex conjugate of the bottom part. Okay, so we can see here that it's the bottom part that I'm getting the complex conjugate of. And then I multiply the top and the bottom by that. And what that does is that we end up with a sum on the top that we'll have to multiply out, and similarly a sum on the bottom. Our sum on the bottom tends to work out quite nicely and give us just a whole number that we can deal with a bit easier. So multiplying out our brackets, I get minus 12 plus 9i plus 16i minus 12i squared. Okay, on the bottom I get 16 minus 12i plus 12i minus 9i squared. Okay, now we need to take note of one of our key points, this I squared. What did they tell us at the start of the question I squared was? I squared is minus 1, so we need to use that now. So on the top I have minus 12 plus 9i plus 16i, so we can combine that together. The 9i and the 16i, that all together is going to give us 25i. And then the minus 12i squared is minus 12 by minus 1. Okay, remembering I squared is minus 1. 16 minus 9 by minus 1. Okay, working that out now, we've minus 12 plus 25i plus 12 all over 16 plus 9. The next parts of the minus 12 and the plus 12 will divide into each other. We get 25i over 25, which gives us I. And if we want to write it out nice and fully, like they've done in the question there, we can just write it out as z3 is equal to 0 plus I. And you could even say 1i if you wanted to. That would be fine. Okay, so key thing there is dividing by your complex numbers. So let's just write that in exactly what the question is. I'll write these in on the side here. So dividing complex numbers. So if that's something that you weren't sure of, that's what you need to go back and look at. Here now we're meeting another new term, and this is where you're going to have to look at what we call the modulus of a complex number. So the modulus of complex numbers. Okay, the modulus of a complex number. And they've said here z1 is the complex conjugate of z1, so z1 bar. So a complex conjugate, we know that z1 was minus 3 plus 4i. So a complex conjugate, we change the i part, we change the sign, it becomes minus 3 minus 4i. Now let's just take this middle bit. Okay, so I'm doing z1, z2. The complex conjugate of z1 we just worked out, minus z2. z2 we worked out earlier was 4 plus 3i. That was given to us in the question. Do you see the way I'm using brackets here? That's to make sure when we're subtracting this that we don't accidentally make a mistake. So minus 3 minus 4i minus 4 minus 3i. Let's simplify that down. We get minus 7 minus 7i. Okay, we're not fully finished yet. Okay, what we have to find now is the modulus of that. So the modulus of minus 7 minus 7i. Okay, what I would say to you at this point is obviously go look back at your notes, make sure you're happy with how you would approach this question. To find the modulus, we do minus 7 squared plus minus 7 squared. So we're squaring both of the numbers that we have there. Okay, so we get the square root of 49 plus 49. Okay, 49 plus 49 gives us the square root of 98. Obviously from the question here, and we can use our calculator then at this point to break that down a little bit further so that we don't write it as the square root. So let me see with the calculator. Okay, so square root of 98 is going to give us 7 root 2. 7 root 2. Okay, so that'll be our answer for that one. Perfect. Let's look at the next question. Okay, so this is again another exam question. We're told z3 is 2i z2. So let's not overcomplicate things. Do we know what z2 is? We do. We're told in the question z2 is minus 2 plus I. Let's just change that to a different colour. Maybe make it an orange. Okay, now z3 is going to be 2i z2. Okay, what does that mean? That's 2i multiplied by minus 2 plus I. So let's follow that through the same way we would with any other question. 2i multiplied by minus 2 is minus 4i. 2i by I gives me 2i squared. We know already I squared is minus 1. So plus 2 by minus 1. And what we get is minus 2 minus 4i. Okay, next of all we need to plot these. Start with z1. z1 is 3 minus 4i. Go to 3 on the real axis, minus 4 on the imaginary axis. z2 is minus 2 plus 1. Go to minus 2, go to plus 1. Then z3 is minus 2 minus 4. Okay, so we can see it's quite related to z2. Looks kind of similar. Okay. Now again we're finding modulus of z1. That's the modulus of 3 minus 4i. If you remember from the previous question, that means we do the square root of 3 squared plus the square root of minus 4 squared. Notice that we're just taking the number. We're not taking the I part, just the number part. That leaves us with 9 plus 16, square root of 25, which is then 5. Okay, and your modulus should give you a number. You shouldn't have any I parts because you don't include the I parts in your calculation. Okay, interesting question here. We're told z1 multiplied by z4 is equal to 29 plus 3i. And what are we looking for? We're looking for z4. Okay, so find z4. So let's think about it. What can we do? z4 at the minute is multiplied by z1 and we have the answer. What that means for us is that z4 is 29 plus 3i divided by z1. Do we know what z1 is? We do. So let's sub that in instead of z1. Let's write in what it is. It's 3 minus 4i. And now we're back once again to a sum where we need to divide complex numbers. So how do we divide again? So we need to get the complex conjugate of the bottom. Okay, that's our first step, is we get the complex conjugate of the bottom. So 29 plus 3i over 3 minus 4i, and we're going to be multiplying by the complex conjugate of the bottom, 3 plus 4i, top and bottom. Okay, so we're going to get 29 plus 3i multiplied by 3 plus 4i over 3 minus 4i, 3 plus 4i. Let's keep it going. What's 29 multiplied by 3? 87. Okay, what about 29 by 4? 116. So we got 116i. 3i by 3 gives me 9i. 3i by 4i gives me 12i squared. On the bottom, 3 by 3 gives me 9. 12i minus 12i minus 16i squared. Okay, what do we know about I squared? We know that I squared is minus 1. So 87 plus 116i plus 9i, so we can simplify that to 125i plus 12 by minus 1. On the bottom, 9 plus, so the 12i minus 12i just goes to 0. So we get minus 16 multiplied by minus 1. Continuing on, okay, 87 plus 125i minus 12 over 9 plus 16. Let's simplify it down. 87 minus 12, 75, plus 125i all over 25, and that's going to give us 3 plus 5i, and that's our answer. Okay, I will say these division questions do take a fair bit of work, but the main step here is you get the complex conjugate of the bottom part and you multiply by the top and the bottom. That will get you some of the marks for starting the questions, so make sure that's something that you know. How to divide complex numbers, you multiply top and bottom by the conjugate of the bottom, because it's a question they like. Then we can see that a lot of it does end up being the same as we continue on, making sure you can multiply out brackets properly. That's coming back to algebra, knowing that I squared is minus 1. These are all the key things with complex numbers. Looking then at question 3, so let's see, they give us a complex number and then they tell us something else as well. They've actually plotted this one already on the diagram. So z2 is 2z1. Okay, so again, let's do the same as we did the last time. z1 is here. So 2z1 means 2 by 2 plus I. Making that connection again as we said at the start, where the z's are all nearly the nicknames, and then the other bits, the 2 plus 1, the 3 plus 4i, whatever it is, those are like the full name. So sometimes they'll tell us the nickname, we can sub in the full name instead. So we get 4 plus 2i. And we can plot that then, 4 plus 2i, we plot it up here, that's z2. z1 is the complex conjugate, okay, z1 with the bar is the complex conjugate of z1. Write down the value and plot and label it. Okay, at this point we should remember, complex conjugate, we change the sign of the I part, so it becomes 2 minus I. And obviously then that's going to be, and it is actually the reflection in the axis of the previous one, so it's the reflection in the real axis. Investigate if the modulus of z2 is equal to the modulus of z1 plus z1 conjugate. Okay, remember again, modulus of z2, let's start with that. Modulus of z2. As I've said earlier, let me use my colours. Modulus of z2, we can rewrite that using the full name. So instead of z2, we're going to say 4 plus 2i, that's the one we found in the first part, 4 plus 2i, and we know that that is the square root of 4 squared plus 2 squared, so square root of 16 plus 4, square root of 20. Okay, let's pause that one there for a second. Now we want to find the modulus of z1 plus z1 conjugate. Okay, again, we can go from the nicknames to the full names. z1 we were given in the question, it's 2 plus I. Okay, and we use brackets plus z2, or z1 conjugate, sorry, which we've said is 2 minus I. Okay, let's just simplify that first, so it's 4. Nice and simple. Okay, the modulus of 4, we can go through it, but we might be able to recognize that it's just going to be 4. Okay, so is the square root of 20 equal to 4? And obviously it's not. Okay, so what that means for us is that the modulus of z2 is not equal to the modulus of z1 plus z1 conjugate. Okay, so that's all we needed to do for that one, is just investigate. So investigate just means, is it? Work out and see, is it actually, or is it not? And it might not be. Okay, it would be different if they said prove, then that means it definitely is, but investigate means it might be, it might not. So just show me. Key things there obviously are working out both sides, being happy that you've worked those out accurately, and then demonstrating that it's not equal at the end and making that really clear and writing that out as we did here. Just writing out that step. Okay, I think this is the last one. Yeah, lovely. Show that z1 equal to 2 plus I is a solution of the equation z squared minus 4z plus 5. Okay, how do we show that something is a solution of an equation? So if it's a solution, then when subbed in, it should give 0. So if it is a solution, when we sub it in, we should get 0. Okay, so we can try that. The other way that we could answer this question is we could try to solve the equation. So we could just try and solve that equation and show that this is one of the solutions. So we'll try either of these methods or solve the equation. We're going to try both these methods. So first of all, let's do this one first. Method 1 here. So if it's a solution, when we sub it in, we should get 0. So 2 plus I squared minus 4 by 2 plus I plus 5. 2 plus I squared. We can write that out for ourselves, even if we're just afraid that we will make a mistake multiplying out the brackets. We can write it out there just in full for ourselves. That's going to give us 4 plus 2i plus 2i plus I squared minus 8 minus 4i plus 5. Let's tidy this up a bit. Focusing on the numbers, 4 minus 8 plus 5. Okay, so that's going to become 1. Focusing on the i's, 2i plus 2i minus 4i. So that's going to be 0i. Then looking at the I squared becomes minus 1, minus 1. Sorry, I should keep the colours the same here. And that's going to be 0. So 0 is equal to 0. Keep that equal to 0 in the whole way down. Okay, so then we're saying 2 plus I is a solution. Or even instead we could actually use the nickname Z1. Z1 is a solution. The other way I said was to solve the equation. And how do we solve a complex equation? Okay, we need to look at it first and see what sort of question it looks like. And even though we're using z's, we should be able to see that it actually looks the same as a quadratic equation. So to answer it, we're going to use our quadratic formula. Okay, b squared minus 4ac over 2a. For this question, b here is the minus 4, so that becomes 4. Plus or minus, sorry, excuse me, shouldn't be zooming in there. So minus 4 squared minus 4 by a, so a is just going to be 1, and c is going to be 5. So c is 5 here. And that's all over 2 by 1. 2 by 1. Okay, simplifying down. 4 plus or minus, let's see, 16 minus 20 over 2. Okay, we're approaching something that we just need to make sure we're happy with. Square root of minus 4 over 2. What's the square root of minus 4? Well, the square root of minus 4 actually works out to be 2i. Okay, and that again is something we should recognize from our complex numbers. I is the square root of minus 1, so the square root of minus 4 is the same as the square root of 4 multiplied by the square root of minus 1. And that then is 2 by the square root of minus 1, which is the same as 2i. If we divide that 2 in, we get 2 plus or minus I, and that then means that Z1 is a solution. So either of those would work. For that particular question, the first method was probably easier. Just sub in and show that it is a root of the equation, that it's a solution of the equation, that when I sub in, I get a value of 0. The second way was just a good chance as well to demonstrate how do we solve a quadratic equation with complex, when we have complex solutions, so not real solutions. Okay, so 3 sample exam questions there. The main things coming up we saw were complex conjugate, dividing, simple multiplication, I squared being equal to minus 1, our Argand diagrams, so plotting the diagrams. So lots of things to look back over. So just make sure that you've done your revision and then tried the questions, and then seen which bits maybe that you need to have a look back over and go back over them. The modulus there as well, so I nearly skipped that one. The modulus came up a fair bit as well. So a few bits to look back over and again just to make sure you're happy with.